Hello, this is Paul from Foresight Tech. In this lecture, we are going to define derivative function and sketch the derivative functions. Okay, and the definition for derivative function is here. What does it mean? Okay, if we fix the x number, if x equals a, can you see what that this mean? This exactly means the derivative at a, right? Or if just c x is a number, and this means the derivative at x, right? What does it mean? It means when x changes, the derivative changes. Therefore, there's a mapping. We're mapping x to the derivative of x, which is a function. Okay, let me give an example here. This is the original function f. Can we see? Give any x, any point of x, the derivative are different, right? The derivative changes. Therefore, if we find all given any x, we find the derivative of x, and then they put the points linked together, we get a derivative function. What does it mean? Let me show a few points. For example, this point on the original, can you see? Okay, this is -1, which means when x equals -1, can you see what is the slope? Derivative, which means the slope, right? Okay, can you see this? Okay, what do we get? The derivative at this is 0. Okay, therefore we make a 1 point. This is -1. That's 0, right? The derivative makes 0. So we make it the first point. Probably you will see we'll make one more point. Okay, like here. How about this point? This point, okay, so can you see this? The derivative, the slope is goes up, which means the derivative greater than 0, right? So we can see this point, of course we have x. So this derivative greater than 0. Okay, how big? Of course this is probably like a 1 or 2 or something. Let me going to find, so probably it's at here. It's positive, right? This is positive, okay? So f prime greater than 0. Therefore, we find a 2 point. So one more. So find one more point like this point. Okay. Can you see this special point? This is 1. Like here is 1, around the 1, and look at the slope is a horizontal line, which means the derivative equals 0 at this point. We're going to find this is 1. Okay, and the value of the function equals 0. That's good. We find one more point. Probably you will say one more. Pick here, probably like a 3 or 4. The derivative is greater than 0, right? This is derivative greater than 0. So 1, 2. This is a 1. I think that's not a 1. Okay, so I think I made it. This is not a 1. So here is -1 is -0.5. Let me see. So here should be 0.5. So here is 1. Okay, here is -1, like that. Here's -1, so there's -0.5. So here is a 0.5. So here is a 1. Okay, 1, 2, 3 more points. Okay, one more point, probably like around 1 point something. Okay, whatever. So probably at here. We find another is f derivative greater than 0. Therefore, we find 1, 2, 3, 4 points. Okay, one more. And look at probably at 0. So here we have the biggest slope. Okay, the smallest. Okay, the smallest. And this time it goes down. Can you see this? The derivative is less than 0. Derivative less than 0. Make one more point. And this less than 0 is how many? Is -2. Suppose. Okay, if we have 1, 2, 3, 4, 5 points linked them together, we look like this, the rough graph of the derivative. Okay, and you will say why here is positive. We can look at any point less than -0.5. Or the left, the function goes up. Therefore, all these are greater than 0. And all the middle -0.5, 2.5 it goes down of the original function. So goes down is a minimum, which means what? Goes down, which means the slope less than 0. See, all this is less than 0. And greater than 1, can we see this greater than 1 or greater than 0.5? And the function goes up. The function goes up, which means the derivative greater than 0. See, derivative greater than 0. This is the very basic, okay? And then let me going to summarize all these details so we can go into draw the graph by ourselves. Okay, so we summarize here. So how to graph a basic rough graph. So based on this information, based on the slope information, of course, everyone you know what is the slope, right? Can you see the original function is here, and then we have the slope, and then we have the derivative. Okay, so look at the first case. If the original function increase, which means what? Which means the slope increase function, the slope greater than 0, right? The slope is positive. Because the derivative is the slope, therefore the derivative is positive. Increase derivative positive. If it increase faster, which means steeper. If it's steeper and the slope is bigger, right? The slope bigger, the derivative bigger. Okay. If more steeper, the derivative is more bigger. Is bigger. And another case, if it's decrease of the original function, the slope is negative. Therefore, the derivative is negative. And if decrease faster, okay, which means more steeper but negative, and usually we will say is bigger negative, or you say it's bigger that the slope is negative but bigger in the absolute value, okay, is bigger, or we simply say bigger negative. Can you see? If it's decrease faster, the derivative is bigger negative. And if the original function reached the maximum or reached the minimum, usually we will have 0 on the slope, which means the slope is the tangent line is horizontal. Okay, the tangent line is horizontal, which means the slope is 0. Therefore, the derivative is 0. And this is the basic information we need. Okay, so all this information is basic. Now we use this basic information so we can graph by ourselves. So like this, can we see? So here we have the original functions like a semicircle, right? Okay. The domain is from -1 to 1. So now we're going to graph. So how to get the graph by ourselves? We look at the sum points first. Okay, we look at the sum points first. Let us build a system, build a coordinator. I build a coordinator. So here, like this x, and this y, this y, this x, this 0. Okay, so we already have this coordinate system. Because the original domain is -1 to 1, so all we need to think about is from -1 to like 1, right? Okay. -1 to 1, because only when x between -1 and 1 we can find the derivative, right? So the derivative function only can be defined between -1 and 1. So now we're going to draw some points and then link the points roughly to get the graph of the derivative function. Which point is easy to draw? Look at this point. When x equals 0, okay, that's easiest. We're going to find the tangent, which is horizontal line, right? So what the slope? The slope is 0 in this case. Slope is 0, which means what? Which means derivative equals 0, right? Okay, so we're going to find this point. Derivative should be here. Why? Because when x equals 0, y equals 0. When x is 0, y equals 0. Good. Find one point, move on, find another. We look at probably like here around. How about this point? This point, if we draw the tangent line, and this goes up, right? It's increase. Increase, which means the slope greater than 0. Slope is greater than 0. Here is probably like 1. Okay, we just roughly, okay, probably like is 1. Okay, if I simply say at this point positive, let me write this derivative probably like I simply say is greater than 0. So I give a point. How about the other points on the left side of 0? See, any other point that you draw a slope, you draw a tangent line, the slope always goes up. The slope always greater than 0. Because what? Because any point on the left side is increase. Okay, the left side of function increase. So which means here is all the derivative is positive. Okay, on the left side all is positive. Therefore, all the points on the left is positive on above of the x-axis. but we have one more. If we look at it in this way, okay, if x go from 0 to -1, as x approach goes to -1, and the graph goes increase, is still increase, and they get steeper, right? Which means if you look from 0 to the left, and the tangent line is more steeper, which means what? Which means the slope gets bigger, right? More steeper, bigger of the derivative. Therefore, we can see, okay, here is 0, here is probably 1, here is probably 2, here probably 3, and how about the what? So the function should be goes up, but it goes up to where? Let us look at the last point, end point. How about when x equals -1? If we draw the tangent line, what does this mean? This means what? It's a vertical line. In this case, we cannot define a tangent line. Okay, we cannot define. But you say the slope goes to infinity, right? The slope goes to infinity. And in this special case, which means what? The function will goes up into infinity. Okay, so let me show like this. -1, so I have to draw like this. Okay, -1 here. Why? Because later our derivative function cannot reach here, just gets closer and closer. Now we basic idea, okay, from 0 to -1, the derivative goes up, right? Goes up to what? Goes up approach this straight line, which means this goes to infinity. Okay, this is the one, the basic on the left. So the same, now it's the same for the right side, right? Okay, so any other point, if you see, take any other point on the right, and this derivative greater than 0, or any other point on the right, derivative is also here, sorry, is not. This is positive, that's true. This is a positive. I said this is not a positive. I get it wrong here. It's less than 0. So here is all the negative, right? Okay, so first. So let me explore any points on the right side of 0. Because the function decreases, so the slope goes down. Therefore, the derivative, the tangent goes down. So the derivative less than 0. Therefore, the derivative less than 0, right? The slope less than 0, the derivative less than 0. Okay, so all is less than 0. Now this is less than 0. So how about if the x from here push to right, see, and the graph gets steeper. If it's steeper, which means what? Steeper, the slope gets bigger, negative, but negative. Okay, so goes down, which means this is a decrease. Okay, this is goes down to where? The last end point. Look at this. Okay, if you draw, is what? This is m equals still infinity, right? But of course, this is negative infinity. Approach negative, probably you can say it's negative infinity. Because what? Because all these number goes to negative. So this is negative infinity. So what do we say? So if I draw like this. Now you know the function goes down. Go down to what? Negative infinity. So this function is the derivative function. Okay, we can draw. So any point there is less than 0. The slope, because the function decreases, and then when x goes right, goes to 1, and gets steeper, which means the value of the derivative gets smaller or bigger negative. Okay, bigger, but in absolute value of the negative value. Can you see? Finally we can get this the graph. That's all. Thank you.